Okay, let's have a look at another example. Let's have a look at magnesium chloride. Okay, so magnesium's over here, and it's got an atomic number of 12. So 12 protons, 12 electrons. It's in group 2, so it's got 2 outer shell electrons. So I'm only going to draw the 2 outer shell valency electrons just to make it a little bit quicker. So there's magnesium, and let's use chlorine again. So magnesium chloride, and as we know because we've done it before, chlorine's got 1, 2, 3, 4, 5, 6, 7 valency electrons. So what happens now? Well, magnesium can give one of those electrons to chlorine. So chlorine's happy. Well, this chlorine's happy because it's got a complete outer shell. Magnesium's still got 1 extra electron to give away. So what we can do is get another chlorine. 1, 2, 3, 4, 5, 6, 7. And then they're all happy because this electron from magnesium can come over here. Magnesium will now have no electrons on the valency shell. Now the second last shell will be the outer shell. And these 2 electrons ended up on chlorine. So we've got a strong ionic bond and a salt magnesium chloride. So instead of drawing that all the time, quick way to do it, we know that magnesium is going to form an ion of 2+. We know that chlorine is going to form an ion of -1. And it's 2+, if you're wondering why is it 2+, well, it's got 12 protons. Protons don't change. It had 12 electrons, but it lost 2. So now it's got an overall positive charge. So 12 minus 10 is still positive. So +2. So that's how we got +2. So what we can do, quick method, is swap and drop. Instead of drawing it out to find the ratio of how many chlorines you need to get rid of all the electrons of the magnesium, what you can do is swap and drop. So magnesium, the 2 from the magnesium, now it's not a charge anymore. It's going to represent the amount of chlorine atoms. So it becomes a formula. So MgCl2. And the 1 from the chlorine, when we swap and drop, we do swap and drop both of them. But because there's a 1 on the chlorine, we never write the 1. Just the negative means it's a 1. Because we never write a 1 in a chemical formula, because having the name of it means there is 1 there. So we have actually swapped and dropped the 1, but we never write 1 there. So whenever it's a charge of 1, positive or negative, and you swap and drop, the fact that you've got the letters there is enough. You don't write the 1. So it's always just going to be MgCl2. And what that means is, it means this whole molecule, MgCl2. We can't change that. That's the way that magnesium is going to bond to chlorine to form an ionic compound that's stable where all the electrons are accounted for.